Everyone, welcome to this video. In this video, we are going to uh, implement convolutional networks in Keras, and the target of this video is not to get into the details of what CNNs are. In fact, the target is to implement them with and play with them with the help of a real world dataset. Okay, so there are many toy datasets available. By toy dataset, I means the datasets that people use for machine learning or learning, deep learning stuff. One of those is MNIST. In MNIST, we have numbers from 0 to 9 in a handwritten form, and the target and their actual number is the label of the images. So the target is to train a model to to identify what is being written by a person if you show you it the image. Okay, so to import one of these famous datasets, you can use the dataset class of Keras, and what I'm doing right now in this line is I'm importing amnest. So calling the amnest data load underscore data function is going to return four numpy arrays. Okay, numpy is a special type of array in Python, and that is used for numeric applications. In case of data science and machine learning or artificial intelligence, NumPy is extensively being used. Okay, so it returns 80% data as training data and 20% as the testing data. Okay, so in order to print or show the image which is saved as a NumPy array, you can use this library that's called matplotlib, and I'm importing this library as PLT. And if you call its function IamShow and pass it the numpy array, so basically all these arrays have images, right? Every index of them have images. I'm talking about X, the data, and Y are the labels. So I'm passing it index number 2. At index number 2, we have the 4. Okay? Right. Right. Moving forward, I'm just checking the shape of these images. So for that, I'm checking the shape of just one instance of these arrays. For that, I call the function shape. So the syntax is something like this: x shape. If you write something like this, x shape dot xtrain dot shape, it's going to print 60,000 comma 28 comma 28. So that's going to show you that that array has 60,000 instances, 60,000 images, and each image is having this shape. So I was interested in getting the shape of the image. That's why I printed the shape of that individual instance or index. Okay, moving forward. Uh, as I told you that these are numpy arrays, that is being confirmed in this statement. Type is a function in Python in which if you pass the variable, it's going to return you the type of that variable. So it's telling you that it's a numpy and the array. Okay, and now I'm reshaping these two arrays. What I'm doing is that I'm appending. Basically, this is the actual shape, and what I'm doing here is I'm appending one. One means the channel. So these images are basically grayscale images. Grayscale, let me show you what grayscale images are. These are grayscale images. Means the images which have two values, basically which have intensities of just one color, black and white, and that intensity ranges from 0 to 255. Okay, so the normal color images are basically three channel. They have R, G, and B channels. So in case of CNNs, you do add the number of bits here, right? The number of channels here. That's why I'm reshaping it to bring it to a standard form. Okay, then just for checking purposes, I checked the image corresponding to index number 2 of the training data. I'm checking the label of training data index number 2, that is 4. Okay, and it should be 4. Okay, now I'm converting the labels to one hot representation. So in case of classification problems, we always do this because when it comes to the numeric digits, so the neural network actually get biased. Okay, so it may consider the value of 2 to be more significant than the value of 1, but the fact is these two are just labels. They do not have any importance. These numeric characteristics do not have any significance here. So in order to get rid of those biases problems, we get into this stuff. We convert that into one hot representation. And what do I mean by that? So one hot representation means you first convert the number of classes into numbers. Let's say if we have dog, cat, and elephant, we assign 0 for dog, 1 for cat, 2 for elephant. But in our case, we in fact already had numbers. So we have numbers from 0 to 9. And then you create a vector of that is of length the number equal to the number of classes. So in case of this application, we have 9 numbers. Okay, and then we assign zeros to all the indexes, but 1 to the index corresponding to the number. So for example, the training instance was 2, which whose values was 4. So the fourth bit 0, 1, 2, 3, 4 should be 1. Okay? Right. So for converting the numeric data to categorical data or one hot representation, you can use this function toCategorical, which is a part of utilities library of Keras. So you write the line keras.utils and import toCategorical, and then you pass the numeric data. It's going to return you the one hot representation data. Okay, now moving towards the actual stuff, the CNN stuff. First, you declare the model. Okay, so if your model is of sequential nature, means you have successive layers, which is the case of normal architectures, you can use a class sequential. Okay, that reduces the number of lines you have to write to make the architecture. Elsewise, there's a functional class which allows you to make any sort of connection. That means you can connect a link from one layer to like the third layer, right? Um, Typically useful in case of architectures like dense layer. Okay? But for simplicity, I'm going for the sequential class. So if your architecture is such that you have a convolution layer of 64 kernels and a convolution layer of 32 kernels, then 16 kernels, etc., and all the connections are successive, there's no connection from the first layer to the third layer or the fourth layer, etc., so then it's always good to use sequential class. So for that, I imported sequential from keras.models, and then I'm importing the type of layers. Okay, so the architecture which I'm making is having 2 convolution layers and 1 dense layer, and that dense layer is going to have the softmax, means it's going to do the prediction. Okay, so there's no fancy stuff. Okay, so I'm importing the 3 type of layers. Okay, dense layer and convolution layer and the flattened layer. Okay, now the question is what is flattened layer? Okay, flattened layer is no special thing. It's not doing any sort of operation. It's just converting your image data into array format. Means it's just stacking all the data together in a sequential format. Okay, let me show you with the help of an example. Flattening of CNN. Okay, so we should get some interesting image. Okay, yeah, this is flattening. So what it does is, if this is the feature map, let's say after this layer, it's going to put the data in this format. First three, second 3, then the second 3, third, last 3, the last 3. Okay, and then we can have such fully connected layers. And in our case, we are just connecting one fully connected layer, and in Keras we use the term dense for them, dense layer. Dense layer in our case is having 10 neurons because we have the 10 classes. Okay, and I'm using the activation function of softmax. Okay, now moving towards the syntax of this part. Okay, when you make a sequential model in Keras, what you do is you simply make the function calls to add. You simply write model.add, and in add you pass the layer. Okay, and in first case we are passing the convolutions, two-dimensional convolution layer. In two-dimensional convolution, the first parameter corresponds to the number of filters or kernels. The second parameter corresponds to the size of convolution kernel that's going to be convolved upon. So it is equals to 3. That means it's going to be 3 cross 3. It could be 5 depending upon your choice. Then the activation map you want to apply on it. Okay, so if you want to apply the activation after convolution, you can directly do it like this. You say activation is equals to quotation mark and then write ReLU or tan hyperbola or whatever you want to do. Okay, sigmoid, etc. If you want to do it separately, that's also possible. You just need to remove this from this parameter and then you add another layer that's called activation. So you first need to import it. It's going to be something like this: activation, and then you're going to, in activation, you're going to pass this ReLU. Okay, well, if that's not the case, you can directly do it. Then in the case of first convolution layer, you need to tell it the input size. Okay, and for the successive layers, it's going to automatically understand what is the input size, because it would know from the previous layer that what feature map size is going to be given to the next layer. Okay, okay. Moving towards the dense layer, the first parameter is the number of neurons, and the second parameter is the activation map. Okay, which is softmax in our case. Okay, so in Keras, getting training a model is a three-step process. The first, you declare it, then you compile it. In compilation, you tell it some stuff which I'm going to tell you right now, and then you train it. Okay, so it's create, compile, and fit. Okay, now let's move towards the second step. That is compile. In compilation, you tell it that what kind of optimizer you're going to use, what is going to be your evaluation parameter, and what loss you are going to use, etc. Okay, so in my case, I'm telling it to use the optimizer of Adam. You may use momentum, Metafruit, whatever you like. The loss is categorical cross entropy loss, which is obvious because I'm going for classification problem. Okay, it's not any other problem. Okay, and then I'm telling it the accuracy is my evaluation parameter. Okay, now moving towards the third step, the training step. Now obviously you declare that what kind of let's do if I am having the outputs. You may train it by yourself. I have run this thing already. Okay, so obviously you tell the Keras library that it's going to be what kind of a model, what kind of layers have going to have. Then you tell it what optimizer you're going to use to train it, and then definitely you have to train it. Now you have to pass the data through it. Okay, so that is being done here. You tell it that the training. Okay, the two ways to do it. In the fit function, if you just pass the training data and doesn't pass this part, then it's going to print out the training accuracy in every epoch. Okay, if you tell it that the validation data is this, let's say in this way fashion, validation underscore data, and then you pass this in brackets, you pass x train and y train, oh sorry, test, then it's going to print the validation accuracy and validation loss in every epoch as well. Okay, so you are going to have the idea that what was the training accuracy after this epoch and what is the training testing accuracy after this epoch, and you may plot that to know whether your model is overfitting or not, and then you may use something like overfit, early stopping, etc. We will get into details of that in some other video. How to early stop your model, or etc. How to know it's overfitting or not, etc. Okay. Right. There's no need of this line. Maybe it's used somewhere. Let's. Okay. Yeah, I really believe that there's no use of that line in this code at least. Okay. So once your model is trained, then you can make a prediction, right? And for that, model.predict is the function. Okay. So you may check the accuracy by the predicted values, and you know the labels corresponding to those means y test, so you can compare that to get the accuracy. A good way is to get precision recall and f1 measure, is through classification report from sklearn library. Okay, so what you need to do is you need to pass it three things. You need to pass it the actual variable, the hypothesis or predicted output from the model, which you get it from here, and the output dictionary, which you set to true. Just need to set it to true because you want to get the output, okay, in this variable. So once you get that, you may print it in a beautiful fashion. For that, heat map is being used. If you don't want to do that, printing the report is going to print it in a less beautiful way. Okay, so not need to get into the details of this. All you need to do is to pass your variable here. It's going to generate the heat map automatically, the beautiful heat map. And then you can give different colors. You may write blues, you may write reds, you may write greens, etc. S is included in the color name to make the heat map in the color combinations of that particular color you are interested in. So we are having a very pretty good accuracy right now, right? And here is the classes. You can get these evaluation parameters for individual class here, okay? Which I believe is good to know the performance of your model, because although this is a pretty balanced and nice data set, but in case of unbalanced data sets, getting F1 precision recall is important. That's it for this video. If you like it, give it a thumbs up. I will come back with another video in which we will be implementing RNNs. Okay. Thank you very much for watching. Take care. Allah Hafiz.